All right, SAT practice test 1 calculator version. So notice you have 55 minutes, 38 questions. 30 of those are multiple choice and the final 8 are short answer. You have your reference sheet here. And let's go ahead and let's get started. All right, starting off with number 1. It says John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during the workout. On which interval is the target rate strictly increasing, then strictly decreasing? And they want to know what interval, so what block of time. So I kind of look at the chart here and I see that on the y-axis, this is his heart rate over here, target heart rate, and then the bottom is the time in minutes. So strictly increasing and then decreasing. So I'm going to, I got a couple ways. I could look at the chart, like I already see a spot that jumps right out to me, that right here we're strictly increasing, his heart rate's going up, and then all of a sudden it turns around and comes back down. And that interval goes from 40 to 60 minutes. So I believe B would be the correct answer there. And if we kind of go through and we look at the other answers, part A, between 0 and 30 minutes, well, we were increasing for the first 10 minutes, but then our heart rate stayed the same. So it couldn't be that interval. Part C, 50 to 65 minutes. So if I'm looking at 50 to 65, that would be from here to here. So it looks like we go up, we go down, then we kind of start to go up. So it's not going to be that one. And then from 70 to 90, we stayed the same. We went up, we stayed the same. And so it's not that interval either. So the correct answer for that one would be B. All right, moving on down to number 2. Looks like some algebra here. I don't see any power. So the first thing I kind of look for is, is it linear? And I know it's linear when there's only an x term. If there were an x squared term, we handle those a little bit differently. Those are quadratics. So, but we're dealing with just x's, so let's read it here. If y equals kx, I kind of like to just rewrite it down, where k is a constant. So remember, a constant is just some number that doesn't change. And y is 24, so I'm going to substitute. So y is 24 when x is 6. So we still don't know what k is, and this is implied multiplication. So, and then it says, what is the value of y when x equals 5? So the actual question starts here. What is the value of y when x equals 5? Well, first off, I'm going to go ahead and solve this equation for k. So I'm going to divide both sides by 6, and I find out that k is equal to 4. Now, that's not the answer. They didn't say what is k, but I think I'm going to need that answer. So now in the second part, it says, what is the value of y? So we're trying to figure out what is y when x is 5. So I go back to my original equation here. Go back to the original equation. When x is 5, and I now know what k is. K is 4. So y is going to be 4 times 5, or 20. So the correct answer there is C. So I kind of call that a solve-resolve, is kind of the method that you'll see over and over on the SAT, is solve-resolve. It's worded a little bit differently than you would see it in an algebra class, but the skills are pretty much the same. Number 3 looks like a geometry problem to me. So we come over here to number 3. It says in the figure above, lines L and M, so that's these horizontal lines. These guys are parallel. So I'm going to mark those as parallel and get rid of that. So you're parallel. And then also the other ones, S and T, are also parallel. So S and T, those little arrows just mean that they never cross each other. If the measure of angle 1 is 35 degrees, so right up here, angle 1 is 35 degrees. We need to figure out the measure of angle 2. Well, parallel lines work kind of in a way where vertical angles always, no matter where two lines cross, those are always going to be congruent or the same. So those are both 35. Then we kind of use the property that straight lines are 180. If you think about a straight line is half of a circle, and a full circle is 360, so that means it's 180. So 135 to get to 180 when I subtract, that would be 145. And then basically this is just a copy paste to all other intersections since the lines are parallel. So these would transfer down here, and it looks like the measure of angle 2 is 145. So that kind of always plays out with parallel lines. There's fancy names for angles, you know, alternate interior, alternate exterior, but the relationship is the most important piece. All right, let's move along and let's look at number 4. So number 4 says, if 16 plus 4x is 10 more than 14, what is the value of 8x? So I think this is another solve-resolve. So let's handle the if part first. So let's try to translate this into an equation. If 16 plus 4x is, well, this part's kind of the part that's awkward. 10 more than 14. You know, a lot of kids are thinking they mean like 10 more than 14, but that doesn't make any sense. But I can see where you would think that. But 10 more than 14 is just a fancy way to say, you know, what's 10 more than 14? Well, it's 24. I don't know why they just didn't say 24, but they try to trick you like that. So now I go ahead and I'm going to solve the equation for x, and I'm going to subtract. I want to get the x by itself, so I'm going to subtract 16 from both sides, and I get 4x equals 8, and divide both sides by 4, and I will get x equals 2. Now, they want you to pick this answer, but don't do it. That's a trick. That's for kids that don't finish the problem. The actual question says, what is the value of 8x? Well, the value of 8 times x, now that we know what x is 8 times 2, which is 16. This is the correct answer. Do not pick that one. That's the one that they want you to choose, so that you'll miss it and there'll be less people get it right. All right, let's scroll on down and go to number 5. And it looks like number 5 is a scatter plot, and I'm going to actually shrink the page here a little bit to make it a little bit easier to see. All right, that looks a little bit better. Number 5, so which of the following graphs shows a strong negative association between D and T? So the key word there that we need is negative. So a negative association, you can kind of think of that as a negative slope. So kind of in general, when you're increasing from left to right, that would be a positive correlation. A strong negative correlation would be decreasing from left to right. So that's negative. And then the only other thing that can kind of happen is no correlation, which no correlation are just a bunch of dots and there's really no pattern anywhere. So kind of looking at part A, to me, this it's kind of negative. It's generally coming down, but I would say it's weak negative. And it's weak because the dots are really far away from the line. They're not packed in nice and tight. You know, looking at part B, there's really not much of a correlation here. Just kind of, it doesn't really flow, you know, positive or negative. C is a pretty strong positive. So I'd say this is a strong positive. And I'm showing you all these because on the test that you take, they might be different than a strong negative. So I want to explain those to you. And part D is coming down. The dots are tight, but this one is definitely the answer. This is a strong negative correlation. So the correct answer for number 5 is D. All right, let's take a peek at 6. 6 looks like a science type question, so looks like some conversions maybe. So in the box it says 1 decagram is 10 grams and 1,000 milligrams is 1 gram. Let's try to answer the question here. So a hospital stores a type of medicine in a 2 decagram container. So we have a container, and I kind of like to draw these out just a little bit easier for me. So this container is 2 decagrams. And from the picture up above, if 1 decagram is 10 grams, 2 decagrams would be 20 grams. So it looks like each container holds 20 grams. How many 1 milligram doses are there in that container? Well, if 1,000 milligrams is in 1 gram, all right, 1,000 in every single gram, if there's 20 grams, I'm going to multiply 20 times 1,000 for a grand total of 20,000 milligrams mg. So I believe the correct answer here is D. Now there's some other ways to do it, a little bit more, I guess, like a science teacher would be. So maybe I can show you that way here. All right, so let's take a look at that method, maybe a different way how you'd see it in science class. So basically we have to go from a 2 decagram container, and we're trying to figure out how many milligram doses that would be. So we need to go from 2 decagrams, which I'm just going to write as dg, and then eventually we want to end up with milligrams. So we have to use conversions to make that happen. So I'm going to just put this as a 1 underneath to start it out as a fraction, because it's just going to be a series of fractions. So let's multiply. If I want to get rid of decagrams, I got to find a conversion. Well, right here is one. 1 decagram is 10 grams. And to cancel decagrams out, I need to put it on the bottom. So 1 decagram is 10 grams. I'll just put a G for that. But I don't want grams. I got to get to milligrams. So I got to cancel grams out. So I'm going to cancel grams out, and I'm going to put it on bottom. And to cancel grams out, I need a conversion, and I have 1,000 milligrams is 1 gram. So 1,000 milligrams is 1 gram. And why I position those that way is because if I can put the same unit on top and on bottom, they can cancel out. So my decagrams canceled out, my grams canceled out, and now I'm left with what I wanted. I wanted milligrams. And now to multiply fractions, you just go straight across. So 2 times 10 times 1,000 is 20,000 milligrams. And on the bottom, in this case, 111 is just 1. So that gives me an answer of 20,000 milligrams. So that's kind of a more formal science way of converting units like that. All right, let's move on along to number 7. Number 7 looks like a bar graph here. So got to kind of read the graph and see what's going on. It looks like rooftop solar panel installations in 5 cities. So I don't know the names of the cities, but I do see down here that there's 5 of them. The number of rooftops with solar panel installations in 5 cities shown above. 5 cities, not shitties. If the total number of installation is 27,500. So here's my first clue. The grand total is 27,500. I'm going to kind of write that off to the side. What is an appropriate label for the vertical axis? So vertical axis is right here, up and down. Well, you know, they're wanting me to know, are we talking tens, hundreds, thousands, or 10,000s? So I got to kind of look at the numbers here. Well, right here, this chart is 9. This chart goes up to 5. This one goes to 6. This one goes to 4. And over here, this is, you know, looks like maybe halfway or something, maybe 3.5. Well, when I add all those up, you know, 9 plus 5 is 14, plus 6 is 20, 24. There's 27.5. So looking at the graph, if they did not give me this clue right here, I would think there was 27.5 installations. But basically, what do I need to multiply that by to get down here to 27,500? So basically, I need to move the decimal 1, 2, 3 places to get 27,500. So 3 places means I got to multiply it by 1,000. So the correct answer here is going to be C. The number of installations should read in the thousands. And usually they'll write that over here to the side where they'll say number of installation. And then a lot of times they'll put that in parentheses and they would say, you know, thousands or something like that. But this one was blank because they were asking you what should go there. So number 7 was C. let's go ahead and let's take a look over here at number 8. For what value of n is in bars there, n minus 1 plus 1 equal to 0? Well, this is kind of like a formal equation, but you really don't have to make it a formal equation. First thing you need to know is what these bars mean. A lot of students, we don't really do this a ton in school, so you kind of forget what they are. But what they are is they represent absolute value. And usually the absolute value equations on the SAT aren't terribly difficult if you kind of have an understanding of what they mean. So in general, let me just kind of break this down a little bit. If they say, hey, what's the absolute value of -5? What it's really asking is, it's really a distance. All right, absolute value is a distance, and in our world, the distance is always positive. Okay, we don't say that something is like -5 miles from here. We say that it's 5 miles from here. So distance is always going to be positive. And those bars basically mean whatever's inside there, just make the answer positive. Technically, it's defined as the distance from 0 on a number line. So this question is really saying, hey, how far, or what is the distance of -5 away from 0? Well, it's 5 units. Just like the number 5 is also 5 units away. So, moral of the story is, whenever you see something in absolute value bars, just make it positive. So the absolute value, let's say, of -3 is just 3. The absolute value of +3 is still just 3. Just make it positive. So kind of going back to our original question up here, let me kind of get that stuff off the screen, and let's go back to our original question. It says that the absolute value of something plus 1 equals 0. So this is kind of a more or a less formal way to do it. Let's just think of this thing right here as just kind of some cloud, some idea. Well, think about what added to 1 will give me 0. All right, what could you add to 1 to get 0? Well, the only thing you could add to 1 to get 0 would be -1. All right, that's the only number out there that when you add to 1 you get 0. But the problem is, I thought we were supposed to take the absolute value of something. That's impossible, because I just told you earlier that the absolute value of something has to be positive. And we're saying now that it needs to be a negative number. So this is a trick question. Correct answer is D. There is no such value for n. So kind of a trick question there. All right, let's take a look at number 9. Oh, 9. So here's another thing that you got to pay attention to, is when you see a paragraph or a chart or something that refers to multiple questions. So you definitely need to look at the bold print here that says, hey, questions 9 and 10 go with the following information. So we're going to take care of 9 here first, and then I'll scroll down and we'll pick up 10. All right, so the speed of sound wave in air depends on the air temperature. The formula above shows the relationship between A, the speed of sound, in feet per second, and T, the temperature in Fahrenheit. All right, so let's kind of, what happened there, get back into read mode. Let's kind of see what's going on. So A is speed, and T is temperature. So just kind of looking at the equation, it looks like when the temperature is 0, you know, if I were to just kind of cover up T is 0, this would go disappear. It looks like it's sound travels at 1,052 feet per second if T was 0. And then it looks like as T gets bigger, you know, for every 1 second, or for every 1 degree Fahrenheit, excuse me, I would add 1.08 degrees to that. So it looks like the hotter it is, the faster sound travels. So let's see what the question is. Number 9 says, which of the following expresses air temperature in terms of speed? So this is kind of a common idea here on the ECT. They want temperature in terms of speed. So basically, when they say in terms of, that means they want temperature in terms of something else. So another way to do this is just, hey, solve for T. So let's kind of crank this equation out. I have A equals 1,052 plus 1.08t. And I need to solve it for t. So trying to get t by itself, the first thing I'm going to do is I'm going to get rid of this 1052. I'm going to minus 1052 from both sides, which I really can't do anything on the left because I don't know what a is. So I'm just going to write a minus 1052 equals 1.08 times t. And then my last move to get t by itself is I'm going to divide by 1.08 and divide everything by 1.08, and these are going to cancel, and basically t is going to equal this expression. So I go over here on the left, and it looks like the correct answer here is A. All right, so we got number 9. Let's scroll down, and that's common. Asking for something in terms of just means you got to resolve it for a different letter. But let's go on down and see over here. It says, which of the following air temperatures will be the speed of sound? So let me get that equation back up here. The speed was 1052 plus 1.08 t. And it says, which of the following temperatures? So basically, at what t will the speed of sound be closest to 1,000? So I want my sound to be 1,000. So one way I could do is I could set this up and say, okay, I want A to be 1,000, and 1052 doesn't change. And now I'm basically trying to figure out what t will give me an answer of 1,000. So I kind of do the same thing as before. I could have just used actually the formula up above, which would have been really nice. But let's go ahead and let's just do this. I'm going to minus 1052 from both sides. And that's going to give me negative 52 equals 1.08 t. Last move, divide by 1.08 and divide by 1.08. And I'm going to punch this in just to be careful here. Negative 52 divided by 1.08 gives me an answer of negative 48 point, and there's some other stuff here, 148 roughly. So it looks like the answer that's closest to that would be B. Although the answers are pretty tight. Normally they're not that close together, but I believe the correct answer for this one will be B. I also could have used the equation that I had up above. You know, I had an equation up above that basically said A minus 1052 all divided by 1.08 equal T. I already had that from number 9 up above. And basically I could have just stuck 1,000 right into this equation and just put 1,000 in there, and I could have solved it that way as well. If you're really no good at solving algebra and you weren't good at number 9, let's say that you drew a blank and you couldn't solve it for t. Another way, I wouldn't really recommend this way, but the slowest way would be to use the original equation, 1052 plus 1.08 t, and you could just start trying answers. Now, since the answers do go in order from big to small or small to big, I would start with one of these two. Usually I'll just start with B, which I'd have got lucky here. But I take that B and I would just plug it right in and just jam that in your calculator. You know, just punch into your calculator 1052 plus 1.08 times negative 48 and see what answer you get. And if you get 1,000, then you know you got the right answer. That would by far, though, be the slowest way, is to plug all that stuff in. But it would work. All right, let's scroll back up. Let's look at number 11. So number 11 looks a little bit tricky in that it says, which of the following numbers is not a solution to that inequality? So I'm looking for it to not be a solution. You know, right off the bat, looking at this problem, if you're not really unsure how to deal with these inequalities, the big thing that you have to know is you have to know that when you have an inequality, the bigger number is going to be on the side that's open, and the smaller number is going to be on the side that's closed. And when we were little, we kind of always threw some teeth on here and said the alligator was hungry. It was biting the bigger side. So you might have heard that at some point. So I could just stick some numbers in. So I could just stick 1 in, see if it worked, try 2, try -3, try -5, and one of those will make a false statement. So I'm going to do that second, but let me just solve it the algebraic way first. I'm going to treat this exactly like an equal sign. Solve it the exact same way. But the one thing I do have to remember is if I multiply or divide by a negative number, I have to flip the sign. So that's usually what gets people. So quick rule to remember, if you multiply or divide by a negative, you must flip the sign. You have to do that. And let's see if that comes into play. Maybe it doesn't. So when I look at this thing, there's a lot of different ways to start, but I'm going to get all my x's to one side. So I'm going to subtract 3x. I like to subtract the smaller variables so that my variables end up being positive, so I don't have to worry about this step. And if I do that, I would get -5 greater than or equal to 1x, take away 3. And now to get x all by itself, I'm going to add 3 to both sides. So add 3, and I get x is less than or equal to -2. But now I got to interpret this answer. You know, x is smaller than -2 or equal to. So looking at these numbers, all of these numbers are smaller. -5 is less than -2. -3 is less than -2. -2 is equal. So the only one that doesn't work is -1 there. Now you might have some teachers that have taught you to do it on a number line, and you kind of draw out this number line and you put 0 here. And if this expression here where x is less than or equal to -2, you would kind of put your -2 right there, and less than or equal to, since it's equal to, I will shade this in, and then less than -2 is this way. So this is the solution set. And so if you notice, all of these other numbers, -3 lives in the solution set, -5 lives there, but -1 is right here, and it's not in the solution set. So you might have interpreted it on a number line if your teacher kind of taught it to you that way. And then just a good old-fashioned way is just take your answers and try them. Let's just stick this in and try it. 3 times a -1 minus 5. I'm going to compare that to 4 times a -1 minus 3. And over here I would get -3 subtract 5, which you never really subtract, you add the opposite. And then over here I would get -4 take away 3, or add the opposite. And then I ask myself, is that true? Well, that's false. -8 is not larger than -7, and we wanted it to not work. So that would have been another way to tell me that A is the correct answer. If you would try any of these other numbers, they all would have made the inequality true. So several ways to do that problem. Moving right down, number 12 here. Looks like, before I even kind of read the passage, I like to try to see what we're talking about. So the title says the number of seeds in each of 12 apples. So my number of apples are on the side. So this is kind of a little bit different. Number of apples are over here. The number of seeds are on the bottom. Well, seeing 12 apples doesn't really jump out at me, but it looks like how I read this chart is, it looks like there were 3 seeds here in 2 different apples. So it looks like there were a total of 6 seeds there. 3 seeds in 2 different apples. There were 5 seeds in 4 different apples. So if there were 4 apples and each one had 5 seeds, that would be a total of 20 seeds there. There were 6 seeds in 1 apple. And then there were 7 seeds in 2 apples. And then there were 9 seeds, right here, 9 seeds in 3 apples for a total of 27 seeds. Now I'll show you why I did that, because it looks like the question, it says, based on the histogram above, which is closest to the average, fancy word is the arithmetic mean, number of seeds per apple. So if I want the number of seeds per apple, basically what I have to do is I have to divide the total seeds by the total apples. So the total number of seeds is, and let's add this up, we have 6 plus 20, that's 26. 6 more is 32. Add the 14, that's 46. And then finally I add in the 27, and that looks like there's 73 total seeds when I add each of these seeds up. So 73 seeds. And they told me at the top that there was 12 apples. I also could have added, the 2 and the 4. If they wouldn't have told me that, I could have figured it out. But 73 total seeds for 12 apples. When I divide that out on my calculator, 73 divided by 12, looks like 6.08. So 6.08 seeds for every one apple. So I believe the correct answer here is C. But the tricky part is just understanding that histogram and how it's set up to get the total seeds. It's a little bit different maybe than what you're used to. All right, so moving on down, number 13. So 13 is a table, and the tables here are a little bit challenging, especially the first time that you see them. And this is a pretty big one. There's a lot going on. So there's two ways you want to look at it. You want to look at this table vertically, going up and down. And then you also want to look at it horizontally, going sideways, because there's totals in both directions. So when I just look at the table, let me explain it. In Algebra 1 class, in Algebra 1, there were 35 girls, 44 boys, for a total of 79 algebra students. And then going vertically, same thing with geometry, girls, boys, total for geometry. Algebra 2, girls, boys, total for Algebra 2. Now, going horizontally, going across, I could look at it just females. So females, that I have algebra females, geometry females, Algebra 2 females, for a total of 150 females. Looks like I had 160 males. And then this number in the corner should be the sum of these numbers, and it should be the sum of those numbers. So that corner number is everybody, the whole survey. So let's get to the question. Now that I've kind of explained the table, let's see what they want. A group of 10th graders responded to a survey. They were asked which math course they were currently enrolled in. The survey data were broken down as shown. Which of the following categories accounts for 19% of all the respondents? All right. So 19% of all the respondents, which we just talked about that, there's 310 here. All right, so first thing we need to know about is percents. How do I find 19% of 310? The fastest way to do that is you change the percent to a decimal, which is divided by 100, or move the decimal point 2 to the left. So 19% is 0.19, and then you multiply it by the total. That's how you find the percent of a number. So 0.19 times 310 comes out to be 58.9. So it's exactly equal to 58.9. So we're going to call that about 59. And so then it says, which of the following categories represents 59? Well, looking up at my chart, it looks like right here, there's my 59 in the chart. So what does that represent? 59 represents males that were in geometry. So males taking geometry, the correct answer there is C. So those tables are a little tricky when you're first trying to figure them out, and they oftentimes involve a fraction or a percentage, which is a whole separate skill. So when you miss this problem, you need to identify A, is it a percent issue, or B, is it a reading in the table issue? And I really like Khan Academy has some really good table data that you can get some practice problems on there. All right, so let's check out number 14. 14, it looks like our tables represent the lengths of fish. So the nice thing about this table is it does look like that it's in order for me. So the smallest fish was 8, The largest fish was 24, and then a whole bunch of stuff in between. Scrolling down and not even reading the paragraph, but I kind of cheat and I'm looking at the answers. I'm seeing mean, median, range, or they will all change by the same amount. So I want to quickly just tell you what those numbers represent. The mean, we had a problem like this earlier. The mean is the average. So you add up your total and then you divide by the number, of things that you have. All right. So for this problem, you'd add up, all the total inches, and then you would divide by the number of fish in this survey. And the median, so the median represents the middle number. Okay, and you always have to make sure that you've put the list from small to big before you find the middle number, which they don't do sometimes. On this question, they actually kind of did. And then the range, needing to know what the range is the largest value minus the smallest value. Okay, so the largest value subtract the smallest value. So let's read the question and see what they're after. The only other thing that's not in this question that I'm just going to throw in here is the mode. And the mode is what number occurred the most frequent. What number showed up the most? So in this problem, it looks like I had 4 12s. So in this problem, if they ask you what the mode was, it would be 12 because it happened 4 times. So it says the table above lifts the lengths of the nearest inch of 21 bullhead fish. So if I was going to do the average, if I needed that, I now know the number of fish is 21. The outlier measurement of 24 inches is an error. So this number right here was somebody messed up measuring, or maybe it wasn't a bullhead, it was a northern pike, or it was some bigger fish. So that's an error, so we don't want to count that. Out of the mean, median, and range, which is going to change the most if we remove that from the data? Well, let's think about the average. If I add up all those numbers and I divide it by 21, and then I add up all those numbers except for 24, and then divide by 20, think about how that would change. It changed a little bit. Our average would move down slightly. And then which one, let's see, the median. Will the median change? Well, let's try to find the middle. So the middle of 21, if I have 21 fish, the middle fish would be fish number 11. That would be exactly in the middle. That would put 10 below and 10 above. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the median. This is the middle number. And actually, if I took the 24th number out there and I had 20 fish, the middle would now be like 10.5. It'd be halfway between 10 and 11, which wouldn't change at all. So it looks like the median will not change at all. So that one's not in there. The mean is going to change a little bit, we decided. And I don't want to add up all those numbers to see, because maybe there's something easier, which there is. The range, I believe, is going to change quite a bit. Because the range, if I leave 24 in, the range is going to be 24 subtract 8, which will give me a range of 16. If I take 24 out, the largest value is now 16, take away 8. Whoa, that changed a lot. So my range number changed by a lot if I take the 24 out. The average, it's not going to change by a whole lot. So I believe the correct answer here is going to be C. All right, question 15 and 16 looks like they both operate off of the same picture up here. Get back into read mode. I'm going to shrink this down some just so that we can see everything that we need to see all on one screen. So let's try to make a little bit of sense of this one. It says the total cost of renting a boat by the hour. So this chart's representing the cost. And over here are my dollars, how much it actually is. And then down here is the time. So reading the chart, it looks like if I rent it for 0 hours, meaning I haven't even started yet, it looks like it's going to cost me $5 just to rent the boat. I haven't even taken it out for any time yet. Well, then at 1 hour, if I keep it out for 1 hour, it moved up to $8. So it looks like it's $3 per hour. And then over here, it looks like at 2 hours, it's up to $11. So if you kind of wanted, there's a couple different ways to look at this. If I wanted to kind of do it as a table, I could set a table up, and I could have hours and dollars, and then say, okay, 0 hours $5, 1 hour $8, 2 hours $11, and so on and so forth. Looks like it stays linear, it stays steady all the way up. And my slope, or my increase, is it's going up by $3 every hour. My y-intercept, the y-intercept is where you cross this vertical y-axis, or in this case the c-axis. My y-intercept is 5. So it says the graph above displays the total cost. What does the c-intercept represent? Well, the c-intercept is right here. So that 5 represents basically the flat fee or the starting fee. So it looks like the initial cost of renting the boat. I believe that's A. The initial cost is just how much it is up front. And then you're going to pay more depending on the hour. And if you rent, a U-Haul, or you rent other things, a lot of times there's a certain price, a flat fee to get started, and then it's so much per mile or so much per hour afterward. So that y-intercept, or c-intercept in this case, always represents the flat fee or the initial amount. So you'll use that on several SAT tests. Now, number 16, which of the following represents the relationship? Basically, that graph over there, which one is the picture? Well, remember that in linear relationships, they all kind of start with the format of y equals mx plus b. And this is usually your slope, or your rate of increase, or in some problems, decrease. And then your b represents your y-intercept. In this problem, our c-intercept. So it looks like I'm going to scratch out A and D because their y-intercept, there was no number at the back, so we pretend it was 0. So they're out. And then, so B and C are still in the game, but my rate of change was $3 per hour. We kind of had that from earlier. So I'm going to go with C. And I'm going to tell you, a lot of people miss this question, and I actually missed this question the first time that I did this test because I'm so used to looking at slope on the graph. And when I calculated the slope, I saw that each dot went up 3 over 4. And I'm like, oh, rise over run. So my slope is 3/4. The problem with that is, and they did this on purpose, I believe, the problem with that is every block isn't worth 1. Going up it is, Going up, I went from 8, I went 9, 10, 11. So those were worth 1. But going over, that's not really a run of 4. It's really only a run of 1 because every block was worth 0.25 hours. So if you pick B, you just kind of got messed up on the scale. So be sure when you take the real test that when you look at a grid, you make sure how much each box is worth. And you don't make the mistake that I made before. All right, number 17. Looks like this is function notation. So that's always a little bit different. A couple things I want you to know about function notation is right up here they kind of tell you, which helps you out. But think about y as f of x. All right, x is just normally the same thing, but y is f of x. So when I'm looking at this graph, it says the complete graph of f is shown above for what value of x. So these are, here's a value of 1, 2, 3, 4, 5. X is -1, x is -2. So for what value of x is f of x, or is y at the minimum? So basically just kind of ignore that and think about when is y at its lowest point? Well, y is at its lowest point right here. All right, that's where y is at the minimum. And for what value of x does that happen? Well, it looks like there's -1, -2. It looks like right here at -3, we were at a minimum. So the correct answer for this one is going to be B. So this spot right here, that represents f of negative 3. Or the function, when you plug negative 3 in for x, what do you get for y? So sometimes they ask this thing and they might have just changed it and said a maximum. So if they said, hey, for what value of x is f of x at a max? Well, f of x would be at a max right here, which is at a value of positive 3. So that would have been the maximum. So just be careful when you're doing those type of problems. Number 18, in the xy plane, if 0, 0 is a solution, so when I say it's a solution, that means that it makes both equations true. So both of these equations are going to be true. And remember, in an ordered pair, the first number is the x and the second number is a y. So they're basically saying, hey, when x is 0 and y is 0, the two inequalities up above are true. So then they want to know what's the relationship between a and b. Well, I'm going to substitute these values in. I'm going to plug in 0 for x and 0 for y and see what happens. So in this first equation right here, I'm going to rewrite it. 0 less than negative 0 plus a. Well, cleaning that up a little bit, I have 0 is less than negative 0 is just 0. So I have this. So basically, my conclusion from here is that a is positive. If you're bigger than 0, a is a positive number. So that's what I'm getting out of the top one. Now when I plug the bottom one in and I put 0, 0 in there, 0 greater than 0 plus b, well, that just comes out to be b is less than 0. So this tells me that b, not be, but the letter b, is negative. So I now have two kind of facts here that I can use. A is positive and b is negative. So let's kind of look over here and see which one of these say that. So if a is positive and b is negative, that's true. That says that a has to be larger than b, and a will be larger than b if a is positive and b is negative. Can b be bigger than a? No, because a is positive, b is negative. Absolute values. Well, this is not always true. Even though that both these numbers will end up being positive, it won't always be true. For instance, let's say that a is 5 and b is negative 3. When I put this absolute value in and I do this, that would work because 5 is larger than 3. Remember absolute value, we had a question earlier on this test about it. Absolute value, you just change it to positive. But if I would have had like a is 2 and b is negative 7, let's just say that was a scenario. If I plug those numbers in there and I say a is 2 and b is negative 7, well, once you do the absolute values, that would be saying that 2 is bigger than 7, and that's not true. So C is not in there. And then D, is it true that A equals negative B? No. If I plug any of these numbers over here, just one example of A being positive and B being negative, this is not true as well. So correct answer is A. Kind of a tough question if you don't plug numbers in because you're just looking at a lot of letters and trying to decide what's true. So always plug some numbers in. If they don't give you numbers, plug your own numbers in. That's kind of my solution. All right, let's try number 19. 19 says a food truck sells salads for $6.50 each. So it's $6.50 times every salad. And it is $2 for every drink. So that's what the menu says. And the revenue, or the money that they bring in from selling a total of 209 salads and drinks. Now, it's not 209 salads and 209 drinks, but a total of 209 salads and drinks combined. So for instance, who knows? It could have been 200 salad and 9 drinks. That could be a possibility. It could be 100 salad and 109 drinks. That could be another possibility. So we don't know how the 209 is made up. But we do know the price that they brought in. So a couple different ways to do this. I'm going to kind of just go the old school problem solving route, and then I'm going to go kind of the more formal algebra route. So let's kind of think about this. Let's use some answers here. So they say how many salads were sold on the day. So all of these numbers over here, these are our possibilities for salads. And usually, like I say, if I'm going to choose an answer to start with, I'm going to go with B or C, just because that way if it's too small or too big, I know what direction to go. So let's just try B first. Let's try 93 salads and see what shakes out. So if I had 93 salads, and we know that salads cost $6.50, so let's punch that on our calculator. We have 93 times 650. Well, that would be $604.50. So those are our salads. This is S. And then if we were going to do our drinks, I knew that there was 209 total. So if I do 209, take away the 93 salads, that looks like it's going to be, what, 116? 116 drinks. And I'm going to multiply that out. So 116 drinks times $2 a piece, that's $232. And let's just see what that comes out to. Well, that would come out to $836.50, which, hey, I got very lucky. I plugged in the first number and I got it right. That's pretty rare. A lot of times that doesn't happen. If I would have tried another number, for instance, let's just say that, you know, I do what a lot of people do, and let's just say that I might have started right off and I tried A, because that's what most kids do. If I try A and I did 77 salads, that would be 77 times 650, which would have been $500.50. Well, if I sold 209 things and I take away 77 salads, that would, when I subtract, that would leave me 132 drinks. And 132 drinks at $2 a piece would be $264. And when I add that up, I would be short. It would only come up to $764. So that's how I would know that A is wrong, and I need to increase my number and go up a little bit more in salads. So that's kind of a guess and check way to just plug answers in. If this was an open-ended question where you didn't have answers to plug in, you'd have to use this method I'm going to show you right here, which is basically solving a system of equations. So I'm going to set up two equations. One equation involves the quantity or the number that we have. And let's just call S salads. So when I take the salads and I add that to the drinks, I know that I have 209. Salads plus drinks equal 209. Well, then I'm going to have a money equation. And my money equation tells me what it's worth. So I'm going to have 6.50 S plus $2 times every drink came out to be $836.50. So this is a more traditional way of solving. And when you want to solve a system, I like to eliminate. So I'm going to try to eliminate one of these letters. And I have a whole separate video on solving system of equations. So if you're kind of weak in this area, you may want to go check that video out, and you'll get a little bit more in-depth on how to solve a system of equations and all the methods of how to do it. But I'm going to use elimination here. And to use elimination, I need to get my letters to match up. Since we want salads, we want to figure out what S is. I'm going to try to get D's to eliminate. So I need to get the coefficients here to line up. So I'm going to multiply the entire top row by 2. Because if I multiply the entire top row by 2, this is what I'm going to get. I'm going to have 2 S's plus 2 D's equal 418. So all I did there was I times 2 by S, 2 by D, and 2 by 209. I scaled it up by a factor of 2. So now, this equation I really don't even need to pay attention to anymore. I have a new equation down below. And the beautiful thing is, since my D's match, I can subtract these two rows. And I can do 650 take away 2s, which is 4.50s. 2d minus 2d got eliminated. And now I have one equation with one unknown. I'm going to be kind of careful here. 836.50 take away 418 is 418.5 or $418.50. And now to solve for salads, I divide and I divide. So punching in my calculator, divided by 4.50, and I get 93. So this was kind of the more formal way of doing it. I will tell you though, I think it's faster on this particular problem. If you started in the middle, either here or here, you could probably just crank that on your calculator quicker than you can solve the system. And sometimes that's what's necessary on the SAT. All right, number 20 looks like a percent problem. We have discount, we have sales tax. So if you notice their answers, they're not really looking for the final answer. They actually have it written as an expression. So I'm going to go off the grid for a second, try to show you some shortcuts that the SAT likes to do for percents. So let's just say that I buy a laptop for $1,000. All right, let's just say this is the original price of a laptop. And let's say that the store is running some sort of sale or a discount of, let's say they're going to do 20% off. All right. And then let's say that we are in a state that has a sales tax of 8%. And then finally at the end, we need to know how much we are going to pay the cashier. So here's kind of an old school way of doing it. The old school way of doing it would be you start with your original amount, $1,000. For a discount, we know we're going to take money off, and we're going to take off 20% of that $1,000. And so right now, our laptop would now be a grand total of $800. This would be the new price. And then to find sales tax, we would take our $800, and then we would add to that the tax, which is 8% of $800, which comes out to be $64. And so what we would end up paying the cashier out the door would be $864. So from original to the end, that would be how you do it. Now notice that there are 4 operations. There's subtract, multiply, addition, and multiply. So we'd have to go through a little bit of a process. There's a newer way of doing that, where if we start off with our $1,000, and let's say we multiply by the number 1. Well, 1 doesn't do anything. The price did not change. But if we want to do a discount, we could take away the 20% from 1. All right, so what that would give us, it would be $1,000 times 0.80. And then if we wanted to, after that, do the tax, 1 would not change anything. Okay, or 1 wouldn't change anything. But then we could add to that the sales tax of 0.08. So down here we'd have 0.08. And now we could get the out the door price, which would be $864. So it's a little bit faster to just do kind of this straight idea like that and get to your number. So for instance, if you're in a store and there are some shoes for $125 and you see a sign that says, hey, 30% off, and you're in Michigan and there's 6% tax, a really fast way of doing this problem is $125 is your starting amount. 30% off, 1 minus 30 would be 0.70, because I'm paying 70% of full price. And then my tax would be 1.06. So that would be a very quick way to get the final price of those shoes out the door. So in this case, it would be 125 times 0.7 times 1.06. And I could very quickly, on my iPhone or whatever I have on me, I could figure out how much it's supposed to be. You always want to double check the people at the store and make sure the register's been programmed right. Many times I found it to not be. So let's jump back into the real problem. So the real problem, Alma bought a laptop computer to a store that gave, so the first thing we know is there was a 20% off discount to the original price. We do not know what the original price is, so I'm going to call that X. The total amount she paid to the cashier was P, And we also have to include an 8% sales tax after the discount. You always want to do your discount first because you're not paying tax on full price. So let's kind of set this thing up. So we have our original price, which is X. Then we are going to multiply by our discount. So 20% discount, 1 minus 0.20 would be 0.80. Our sales tax, we need to add that to 1, so that's 1.08. And then we are going to end up with P, what we paid the cashier. So remember, this was the original, and this was how much I actually paid. Well, the problem now says which of the following represents the original price. So we need to figure out the original price. So to find the original price, to get X by itself, we're just going to divide both sides by 0.80 times 1.08, 0.80 times 1.08. This is all going to cancel, and we're just going to have X equals this expression, which matches up pretty nice with D. So that's kind of the fancy algebraic way of doing it. Another way you could do it is you could just kind of pick your numbers. So I could say, hey, let's just pretend we know what the original price was. I'm going to go with $1,000 because it's a nice friendly number. You could pick whatever you want, but $1,000. And then if we do our 20% discount, and then if we do our 8% sales tax, we now could figure out our price out the door, which would be, I believe, 800, let's see, 1,000 times 0.8 times 1.08, $864. All right, so this is P. And this was the original. So what I could do now is I could try their answers. I could take this P number and I could plug it in every single one. So I could do 0.88 times 864. I could do 864 divided by 0.88. I could plug in 864 for P here. And I could plug in 864 here. And the only one out of all of these that gets me back to $1,000 is this one. All of these other ones are not going to come out to be 1,000. So that's another way to kind of pick your own numbers and then plug it back in and do it that way. So that could work. All right, moving on to number 21. It looks like we have a probability problem with a table. So something I could do here is we're talking about dreams. It looks like there's two groups. We have group X where there's 100 people, group Y there's 100 people. So we have a grand total of 200 people. And then the vertical categories, these people had no dreams, 1 to 4 dreams, and 5 or more dreams. So we have some numbers there and some categories to look at. So let's read through the problem and get to the nitty-gritty. It says, if a person is chosen at random from those who recalled at least one dream, all right? So probability is always a fraction. And the people that we're choosing from, whatever comes after this word from, goes on the bottom. So if a person is chosen at random from everybody who recalled at least one dream, well, looking at this chart, you know, these people recalled 1 to 4 dreams. These people recalled 5 or more. So this is the group. All of these people right here are people who had at least one dream. And I believe when we add those up, there is 164 people there. So 164 people had at least one dream. We're going to get rid of the 36 who didn't have it. So if we put all those names in a hat, what is the chance, what is the probability that the person belonged to group Y? So out of all these people here, who belong to group Y? Well, that would be these people right there, which comes out to be, it looks like 79 people. So 79 out of the 164, that would be the probability or the chance. So the correct answer for this one is C. All right, number 22 and 23, these guys kind of go together. We have a table here, and it's the annual budget for different state programs in Kansas from the year 2007 to 2010. One thing I want to point out before you jump into this is that when you read right here, it says the table above lists the budget in thousands of dollars. That means that every single number on this chart needs to add 3 zeros to it. So for instance, this bottom one here, that's really $464 million were spent on public safety, not just $464,000. So be careful, that might affect our final answers. So number 22 says, which of the following best approximates the average rate of change, aka slope if you were talking about a graphing problem, in the annual budget for agriculture from 08 to 010. So we have agriculture from 2008 to 2010, and they want to know the rate of change. So for rate of change, we're actually going to have to figure out how much did it change, or what was the amount of change divided by the number of years. How much did it go up or down divided by how many years that was. Well, I know right away that the number of years was 2 because it went from 2008 to 2010. So over a 2-year period, and let's get some numbers in here now. Our numbers went 488,106. So 488,106,000. Take away, and then we're going to do this guy, and we're going to remember to add our zeros. 358,708,000. And when you put all that into your calculator, it looks like these answers down here, none of these answers are really that precise. So I think we could probably kind of ignore all of this part right here and just use 488 million and 358 million, which looks like it comes out to be $130 million over 2 years. And when you divide 130 divided by 2, that would be approximately $65 million per year. So the correct answer there would be B. Sometimes I cheat at the answers like that to see how precise I'm going to have to be and whether or not I need a calculator. All right, number 23, of the following, which program's ratio, so remember ratio is basically a comparison between two numbers. So you can either use a dot format or you can put it in a fraction format. But we want to check the ratio of the 2007 budget to the 2010 budget. Which one is closest to human resources ratio? All right, well, I'm going to kind of clear this screen out a little bit. We're going to go back to our table. So we need to check out the year of 2007 to 2010 for human resources. So that would be right there. Those are the two numbers. So ratio of 2010 or 2007 to 2010. So I'm going to divide that out. I'm going to do 2007's numbers to 2010's numbers. And really, I don't need to add the zeros in on this problem because when I divide it, it's going to come out to be the same answer. But that ratio comes out to be 0.684. All right. So that's the ratio of 2007 to 2010. What I'm going to need to do then is I'm going to need to go through and I'm going to need to divide these two numbers in every single column and see who's closest. So when I did that, I got 0.76 roughly. I'm kind of stopping it there. You don't need to get too in-depth. This number divided by this number came out to be 0.71, 0.719 actually. This, when I did this number divided by this number, I got 0.97. 07 to 010 for highways came out to be a ratio of 0.82. And then finally, public safety. Looks like it increased quite a bit. The ratio was 0.56. So now I need to find out which one matches up best with the 0.64. And looking through these, the ratio that is the closest would be right there, which would be education. Correct answer for that one would be B. All right, number 24, getting a little bit tougher here. Looking at which defines the equation of a circle in the xy plane. So first, let's kind of go over what the equation of a circle, how you write the formula for it. So circles have a center that we call HK. It's really an X and a Y, but here's your H, and this is your K value. And the circle formula always starts off, it's X take away whatever the H number is, squared. And then you add to that Y minus whatever the K value is, squared. And then the R represents the radius, squared. So kind of going through and looking at my formula here, I know that I'm going to have X minus 0 squared, and then I'm going to have plus Y minus 4 squared. So right away that comes out to be X squared plus Y minus 4 squared. That little fact right there about the center helps eliminate B and eliminates D because both of those had pluses instead of minuses there. So I've got it down to a 50-50, which is huge. Now I just got to kind of lock down this doggone radius piece. So we need to figure out the length of the radius. And basically what we need to do is we know a center point and we know the end point. So the length of that line right there should hook us up with what we need. So I'm going to go ahead and move off the grid here where I have a little bit more room to kind of draw this thing out. So let's kind of put our grid down here, and we're going to go over 1, 2, 3, 1, 2, 3, 4, 5. And it said that our center point was at 0, 4. So here's our center point. And it said the end point was at 4/3, which is over about 1 1/3, and then all the way up here to 5. So that is the radius of our circle. So if we wanted to sketch our circle, we could kind of just kind of freehand this a little bit. But if I want to know how long that radius is, I'm going to have to use Pythagorean theorem. Now, some people prefer the distance formula. I'm not really a big fan of the distance formula. I would rather use Pythagorean theorem. So if you kind of call this A, B, and pretend that the radius is C, I like to use A squared plus B squared equals C squared. Or in our case, this is going to come out to be R squared. So first let's see how long these are. Well, this little A right here, the distance of the length of that black line, well, we're going from 0 over to 4/3. So this is a distance of 4/3. Our height goes from 4 up to 5. So our height is 1. So the legs of our triangle are 4/3 squared plus 1 squared equals R squared. So 4/3 times itself, you could use a calculator or you could just multiply it out. But I get 16 over 9 plus 1 equals R squared. And then depending on if you want to use your calculator, or I would just call 1 9 over 9, I would get a common denominator. So that 25 over 9 is the radius squared. Now if this was a Pythagorean theorem problem, I'd have to take the square root of both sides and I'd have to find out what the actual radius is. All right, but there's really no need to do that because when you look at the problem, this number right here at the end, remember, is the radius squared. So I don't need the radius. I need the radius squared. So that tells me that A is the correct answer because that represents the radius squared. Now, if you would have accidentally took the square root of that 25 over 9 and you took the square root of both of those, you would get 5/3, which would be this answer. So that's a great wrong answer. However, that represents R and not R squared. And that's just not how the formula is built. So that was a pretty tough one. All right, number 25 looks like some sort of a physics question. I see H represents height, T represents seconds, and it's a quadratic. So I got to kind of roll up my sleeves for this one. It's going to be a little bit trickier. The equation above expresses the approximate height of a ball t seconds after it's launched vertically from the ground, initial velocity of 25 meters per second. You don't really need to know that in here, but negative 4.9 is the constant due to gravity if you've taken a physics class. But the main question says, after how many seconds will the ball hit the ground? So the big thing is, what is the height when the ball hits the ground? All right. Well, the height when the ball hits the ground is going to be 0. So basically, we got to figure out what t makes h equals 0. Now, fortunately for us on this problem, I actually have some t's to try. I mean, these are all possible answers that I could put in there and I could try. So one way to solve the problem is just to cheat and use the answers. So I'm going to go up above and I'm going to say, okay, do negative 4.9 times, I'll try the first one, 3.5 squared, plus 25 times t, which we're trying 3.5 this time. And I put those numbers in there. And I crank this out. And I get negative 4.9 parentheses 3.5 squared plus 25 parentheses 3.5 equals. And unfortunately for this one, it comes out to be 27.475. So this would be the height for this problem. So I could kind of repeat this process over and over and over. And actually, if you have a graphing calculator, you could punch this into the y equals equation, and you could use table, and it would really speed up this process. So there's another video I have about using the graphing calculator and some of the shortcuts if you have one of those. So I'm going to kind of go in and put in the other numbers. If you punch in 4.0 in these two spots, you end up with a height of 21.6, so the ball's coming back down. If you do 4.5 seconds, you end up with 13.275. And then if you punch in 5.0, you actually get a value of 2.5. So none of these came out to be perfectly at 0. But 5 was really close. 5 is the best answer there is up there. So if you were just plugging in numbers, the best choice there is 5. So that's a way to kind of use the answers to plug them in. I'm going to show you another method that's a little bit more kind of traditional. And that is, let's solve this algebra equation for h equals 0. We know that that's when the ball hits the ground. So let's solve this equation when h is 0. Well, this is a quadratic equation. We have a t squared and we have a t. So it's not like normal algebra where I can just get t's by itself and divide and somehow get the answer. I need to do a couple of things. I could either factor, I could use a quadratic formula, or I could graph. So I'm going to solve this one by factoring. So the first thing I can do is I can try to pull basically a t out of both of those terms. So I'm going to yank a t out here, and I'm going to have negative 4.9t plus 25. And basically I just did reverse distributing. If I were to distribute here, I would get the exact same thing that's up above. So factoring is just doing reverse distribution. Well, now I'm going to use what's called the zero product property. And the zero product property basically says that if I have something multiplied by something else and it equals 0, one of those two things have to be 0. So the first scenario would be, well, maybe t is 0. Well, that's pretty obvious because when t equals 0, the ball hasn't even left the ground yet. So I know the height's going to be 0 at 0 seconds. It hasn't been launched yet. What I want to find out is the other t. So the other one I have to figure out is, when does this expression come out to be 0? So I need to solve that equation. When does negative 4.9t plus 25, when is that going to equal 0? So I'm going to minus the 25 from both sides, and I get negative 0.49t equals negative 25. And I'm going to divide both sides by negative 4.9 and negative 4.9. And a negative divided by a negative comes out to be a positive. And my calculator says it occurs at about 5.1 seconds. So the closest answer here would be D. So that's kind of more of a hardcore algebra way of solving that equation when h equals 0. All right, number 26. problem about pear trees. I see the word percent in there, so it looks like a percent type problem. So it says, Katerina is a botanist studying the production of pears, two types of trees. She noticed that type A produces 20% more than B. So type A is 20% more than B. And then based on our observation, type A produced 144 pears. So type A was 144. And that's 20% more than B. So basically we have to figure out, we have B, and then when you add 20% more of B, that ends up being 144. So another way to write that is, however much B is, 1.20 would be an increase of 20%. And you could just solve this equation. You could say, okay, to figure out what B is, let's just divide both sides by 1.20. 1.20. And it looks like that's going to come out to be 120. So the correct answer is B. So that's one way to do it, solving an equation. Another way to do it would just be to try their answers. You know, if these are all the type B possibilities right here, and we know that A is 20% more than that, just add 20% more to each of these. You know, add 0.20 times 124 and add 0.20 times 173. Well, first of all, I know it can't be D. I wouldn't even mess with my calculator for that one because that's already too big. But if you go through these and you punch them in, you just keep going until you get 144, which would be B. So that's another option to kind of cheat and use their answers and figure it out. All right, number 27, I see a table, so let's kind of go over and take a peek at this one. It says a square field measures 10 by 10 meters. So let me go ahead and I'm going to just draw that really quick. We have a square field that's 10 meters by 10 meters. 10 students mark off a randomly selected region of the field. Each region has a length of 1 meter. So it looks like we're basically breaking this thing up, and I don't know if I'm going to go through and draw all of these, but let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if we split it up this way, it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 100 grids basically on this field, 100 little plots. Well, 10 students are marking them off randomly. They're going to count the number of earthworms to a depth of 5 centimeters in the soil of each region. So, you know, basically, I don't know, these are our region numbers. So maybe region A is here, region B is there, C is here, whatever, it's just random. They randomly pick little spots because they don't want to check every single region. So they go through there and we have the number of worms in every region. So these are all of our numbers here. Well, then it says, which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? So they want to know how many worms are in the entire field. Well, just looking at these numbers here, these numbers are extremely far apart. So I think I can use a ballpark method on this one to try to figure it out. So looking through here, it looks like the smallest region had 107. The largest region had 176. And kind of just peeking at all these numbers, it looks like somewhere about 150 worms were for every square. So if every single one of these, you know, if that little square right there had an average of 150 worms, and then we multiply it by 100 regions, you know, that would give us 150 and add a couple more. That would give us a total of 15,000 worms. So I believe the correct answer for this one is C. I really didn't have to get all crazy. I think they want you to add up all these and find the average and then multiply it by 100. But looking at the answers, cheating and looking ahead, we saved ourselves a lot of time by not doing that. All right, looking at number 28 here, looks like a graphing problem. So we have a system of inequalities. So the first line that they're saying is that y is greater than or equal to 2x plus 1. So I have to remember a little bit about slope-intercept form. This is in the form of y equals mx plus b. So our slope, it looks like, is 2, which I know what 2 is. I know that it goes up to right 1. That's a slope of 2. And the y-intercept, which is this back number where it crosses the y-axis, is at positive 1. One other thing that might be helpful is realize that when it starts off and it says y is greater than or equal to, that means you're going to shade above the line. So I need to shade above the line. So let's kind of sketch this out. So let's just kind of mark off a little bit here. We'll just call this 1, 2, 3, 4, 5. And so this line, when I draw it, it crosses the y-axis at 1 and has a slope where it goes up 2 over 1, up 2 over 1, up 2 over 1. So here's my line. And the solution to this one, to this line right here, is we're shading everything above that line. So this region over here would be the region that's getting shaded. That's all above the line there. Now I have to graph this other one. So this other line right here is y is greater than 1/2 x minus 1. Well, the key features of this line has a slope of 1/2, which means we're going to go up 1, right 2. And our y-intercept is the back number, which is negative 1. So let's get this on here. We cross at negative 1, and our slope goes up 1 over 2, up 1 over 2. And so this line is going to look something like that. And now we're going to shade pretty much everything above that line. So all of this stuff gets shaded up here. And now the solution to the entire system, okay, because that's what they say here. They say, hey, it says which quadrant contains no solutions for the whole system. Well, the solution to the system is the overlap region. So the region that got shaded twice was basically everything in this area right here. That got double shaded twice. It got shaded by the red and by the blue. So the only quadrant that doesn't have any green in the region, you know, right there, quadrant 1 has some green, a bunch of quadrant 2 has green, some of quadrant 3 has the green, but right here, quadrant 4 did not have any green in there. So quadrant 4 would be the answer to this one. There are no solutions to that system. All right, another possibility for this one, if you didn't really know the graphing part and you weren't really very good at graphing, you also could do a test point in every region. For instance, in region 1, maybe I would test 1, 1, meaning x is 1, y is 1. Maybe over here I would pick negative 1, 1. In this region, maybe I'd pick negative 1, negative 1. And then in this region, I would put positive 1, negative 1. Basically, you pick a point in every region and you test it. You know, these points would live like right in these 4 spots. And you find one that doesn't work for either of them. I'm not going to go through and plug all of these in, but if you test this point right here, if you test that x and that y, it should make both of these true. So for instance, if I try this one, is it true that 1 is greater than or equal to 2 times 1 plus 1? Well, is it true that 1 is greater than 3? No, that's false. So it was a no for that one. And if I try it over here, you know, if I say, okay, is negative 1 greater than 1/2 times 1 subtract 1? So is negative 1 greater than 1/2 take away 1? Well, that's a negative 1/2. And this is also a false statement. Negative 1 is not bigger than negative 1/2. So this is a false. And we were looking for no solution to both lines. So this is the only point that doesn't work for either of them. All of these other points, if you would have tested them, they would have made one of those two lines true. All right, number 29 is kind of a rough one here. This is one of those problems that you don't see a whole lot. This is like one of the only ones I've seen on all the practice tests kind of worded like this, but nevertheless, I'm going to show you how to do it. So just kind of bear with me. Let's kind of go off track for a little bit, but pretend that you have two factors, x minus 3 times x plus 4, let's say. And if you remember how to do FOIL or, the box method, basically we do, first times first and outsides and insides, and then we do the last terms. And when we clean that up, we get x squared plus 1x subtract 12. All right. And this is a quadratic, or in general, it's a polynomial. And these two people right here that were times together to make that are called factors. Now there is a relationship between the factors of a polynomial and the solutions of a polynomial. For instance, this little phrase right here, x minus 3, this equals 0, x minus 3 equals 0 when x equals 3. And same thing for this other one over here, x plus 4 is a 0. When we solve it, you get x equals negative 4. So these two guys are called the zeros of the polynomial, and these are the factors. And you can kind of think of them, I guess, almost as opposites of each other. But there's kind of something interesting that happens. They're called zeros because when I plug them in, they make the equation come out to be 0. So for instance, if I take this very first piece and so let's just try the 3. I'm going to plug the 3 in, and I get 3 squared plus 3 take away 12. You'll notice that that's 9 plus 3 minus 12, which comes out to be 0. The same thing would happen, I'm not going to do it, but the same thing would happen if I were to put negative 4 in there. All right, I would get 0. So using function notation, basically that the polynomial, when you evaluate it with a 3, you get 0. And the polynomial, when you evaluate it at 4, meaning you plug 4 in, you get 0. So there's a relationship here between this number that gives you zeros and the factors. Now, let's just say that we tried to put 5 in there. Let's say we tried to do p of 5. So I put 5 in that equation, and I get 5 squared plus 5 take away 12. Well, that's 25 plus 5 is 30. 30 minus 12 is 18. So we see that p of 5 is 18. Now, if you kind of use the same idea, if we kind of use these zeros here, and you work backwards and you look at the factors, so if this is our number we tried, if I go back and I try x minus 5, and I want to see how many times it goes into the polynomial, this is long division, which you really don't have to do this hardly ever on the SAT, but I kind of need to do it to explain this problem. So x goes into x squared x amount of times, and then you multiply backwards and you get x squared minus 5x. And then you do subtraction, just kind of how you do long division with numbers. And I have 1 subtract a negative 5. Well, that would be 6x, and I bring the minus 12 down. And then x goes into 6x 6 times, and then multiply backwards, you get 6x minus 30. And then when I subtract those two, I get negative 12 plus a positive 30, I get 18. And this is called my remainder. So the big idea is this. When you are trying to evaluate a number into a polynomial, when you look at the opposite of that number, or its factor, the output, the outcome here is always the remainder of the equation. So when I look at number 29, and I see that this p of 3 equals negative 2, what that tells me is that when I work backwards, the factor x minus 3, when I put that into whatever the polynomial is, we don't really know what the polynomial is. They don't tell us. But I do know that when you plug 3 in, we're going to end up down here at the very end getting a remainder of -2. So the correct answer here is D. Not the greatest explanation. It's kind of a really funky, weird topic. I've only seen it once or twice out of all the tests that I've seen, so the chances are that it shows up on the real one is probably not very good. All right, number 30 here, we have a quadratic equation. It looks like we have to match the graph there to the points down here at the bottom. But let's read through and let's take a look. It says, which of the following is an equivalent form? So which of these are equal to the equation of the graph shown above? If you stop right there and you kind of only do this part, there's actually a couple answers down here that work. For instance, A, when you multiply A out and you actually do, you know, the first times first and the outsides, you do this in advanced algebra a lot, and the insides, and then the last, that will come out to be x squared minus 2x minus 15. However, it's not the correct answer because you need to read a little bit further and you need to see from which the coordinates of the vertex, remember the vertex is this lower high point of a graph. The coordinates of the vertex, well the vertex is at x equals 1 and it looks like somewhere around -16. So that's the coordinates of the vertex. So it says, which of the following is the equivalent form where the coordinates of the vertex can be identified as constants in the equation? So that 3 and that 5 don't help me with the vertex. Neither does this one, and neither does this one. The correct answer here is D. If you actually multiply that out, you will get this equation. But in general, the standard form, vertex form for a quadratic is y equals x minus h squared plus k, where hk are the coordinates for the vertex. So that's just kind of another form that you can think about. This one right here is written in what's called standard form, ax squared plus bx plus c. You'll notice kind of these pieces match up there. So this is what's called standard form. And this one down here is called vertex form. All right, starting the free response here, number 31 says Wyatt can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on this info, what is the possible amount of time in hours it would take him to do 72 dozen? Well, let's look at the slow. On the slow end, he can do 12 dozen per hour. All right. So you could set up a little proportion. You could say, hey, 12 dozen for 1 hour would mean he could do 72 dozen in X hours. And we could cross multiply to solve this proportion. You'd have 12x equals 72 or x equals 6. So if he's doing it really slow, he could do it in 6 hours. Some of you guys may not have had to set up a proportion like that. You might just kind of know that you need to divide 72 by 12. You could do that as well. But if he's doing it really fast, he can do 18 dozen in 1 hour. So he could do 72 dozen in X hours. And when you cross multiply, 18x equals 72. And then you divide both sides by 18, you will get 4. So the fastest he could do this job would be in 4 hours. The slowest he could do it in 6 hours. And it says, based on the information, what is a possible amount that he could take to do 72? So it looks like our answers could be either 4, 5, or 6. You're only going to put one of those answers, though. You're not going to mark all of them, just one of those. All right, number 32 said the posted weight for a covered weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. So So that's the maximum you can be. So let me just write that down. The max has got to be 6,000 pounds. A delivery truck that is carrying X identical boxes. So X means we don't know how many boxes it has on it. Each weighing 14 pounds is going to pass over the bridge. So the combined weight of the empty delivery truck and his driver is 4,500 pounds. So it's going to be a pretty bad drawing of a truck. But so we have this truck with the driver inside of it. Just that in itself is 4,500 pounds. Excuse me. But then we have these boxes on the back, and we don't know how many we have, but we do know every box is 14 pounds. And we're driving over the bridge where we cannot exceed 6,000. We have to be less than 6,000. So it says, what is the maximum possible value for X? So what's the most boxes we could carry, basically? I'm going to set up an equation here. We have 14 pounds multiplied by however many boxes, which we don't know, added to the 4,500 pounds for the truck and the driver, needs to be less than or equal to 6,000. So we actually have an inequality here that we can solve. So let's subtract the truck. And you may not have got this formal. You might just right off the bat realize you need to take away the truck and the driver. And you'll realize that 14 pounds times every box needs to be less than 1,500 pounds. And so when we divide both sides by that 14, we find out that X is less than or equal to 107.14. But you can't have 0.14 of a box. So correct answer here would be 107 boxes. Okay, number 33, we have a graph here with the year, and it looks like we have the number of units sold of portable media players, 06 to 11. According to the line graph above, the number of portable media players sold in 2008 is what fraction of the number sold in 2011? Well, we go over here to 2008, and that is 100. And then we are comparing that, what fraction sold in 2011, which is 160. And I don't believe on the SAT they make it to where you have to reduce, but I'm going to reduce it anyway to be careful, because I don't think there's enough boxes for you to bubble in 100/160. You know, that would require 7 boxes. And I think the max they give you is 5. So I'm going to whittle this down. I'm going to divide both the top and the bottom by 10. So that would be 10 over 16. And then I'm going to go even further and divide it by 2. And I'm going to get 5 over 8. Now when you enter this in, you're going to have to enter 5/8 when you bubble in the free response grid. All right, number 34 says a local television station sells time slots for programs in 30-minute intervals. So every 30 minutes they have another slot. So that right there tells me that I have 2 slots per hour. All right, because there's 2 half-hour intervals there. And they do it 24 hours a day. So 2 slots per hour times 24 hours. So that would be 48 slots per day. And then it says they do that every day of the week. What is the total number of slots the station can sell for Tuesday and Wednesday? All right. Well, that's 2 days. So if there's 48 slots per day times 2 days, we're looking at 96 slots available. All right, a geometry problem. Number 35, we have a cylinder here. It says a dairy farmer uses a storage silo that is in the shape of a right cylinder above. If the volume of the silo is 72 pi cubic yards, so the volume is 72 pi cubic yards, what is the diameter of the base of the cylinder? So we're trying to figure out what the diameter is. The diameter is the distance across down here. So first thing I need to know what is the formula for the volume of a cylinder. And if you don't have that memorized, you can go back up to the actual reference sheet. And I'm just going to show you where that is, kind of in the very beginning of the test. So you go all the way back up here on the front page of your test. It's coming right here. And the volume of a cylinder is right there. It's pi r squared h. So if you don't have that memorized, be sure to remember that you can see that at the beginning of the sheet. So I'm going to kind of come back down to our problem here and pick it back up. So we have our 72 pi. Volume is 72 pi. But we know what volume really is. Volume was pi r squared h. That's where they came up with the 72 pi. Well, we can use that formula. We can use this volume formula and the answer to figure out what diameter is. And basically what I'm going to do here is, first thing I'm going to do is I'm going to divide both sides by pi. Well, actually, first, 8 right here represents the height. So that's the height of the cylinder. So maybe we'll put that in. We'll have pi times 8 squared. Check that. We're going to have pi times r squared times 8 equals 72 pi. And we're really interested in getting r because if we can find out the radius is halfway. If we can find out the radius, we just double it, and then we'll have the diameter all the way across. So to get r by itself, this is all multiplication over here. I'm going to divide by pi, and I'm going to divide by 8. And over here, I'm going to divide by pi, and I'm going to divide by 8. And what's going to end up happening is, on the left-hand side, I end up with r squared. And on the right-hand side, these pi's are going to cancel, and 72 divided by 8 is 9. So I know that r squared equals 9. To figure out what r is, to get rid of this 2, I take the square root of both sides. So that cancels out with the 2, and I get r. Take the square root of that side, I get 3. So I now know that the radius of this is 3, which means the diameter, which is the distance all the way across, would be 6. And you don't have to worry about putting the units yards in there. You're just going to put the answer of 6. All right, number 36 says we have a function h of x equals 1 over a whole bunch of crap down there. And it says, for what value of x is the function above undefined? Well, functions are undefined when the denominator equals 0. Because if you try to punch in your calculator 1 divided by 0, you will get an error. Or some calculators just come out and tell you, hey, that's undefined. So whenever they want to know when a fraction is undefined, you basically got to figure out when is the bottom equal to 0. So let's kind of try to go through and solve this. X minus 5 squared plus 4 times x minus 5 plus 4 equals 0. Now, if you were totally kind of clueless here and you didn't really know how to do it, you could just kind of try some numbers. You could try to pick your own x's. I would suggest to pick numbers between 1 and 10, starting small, like maybe 2, 3, 4, 5. And you might get lucky and you might be able to put a number in there and get it to come out. But I'm going to go actually show you how to solve it. So I'm going to work this out. So the first thing I'm going to do is I'm going to do this x minus 5 squared. Then we're going to add 4 times x minus 5, or I'll do the distributing, and see if we can solve this equation. So in this first piece, I'm going to get x squared, that's minus 5x, plus another minus 5x, that's minus 10x. And then negative 5 times negative 5 is plus 25. Then here I'm going to get plus, I got to distribute, so that's 4x minus 20 when I distribute the positive 4. And then I got to bring the 4 down, and I get 0. So now we're going to clean things up a little bit. Over here on the left-hand side, I have x squared. Now I'm going to gather up some like terms. This negative 10x and this positive 4x, they combine to make a negative 6x. And then my numbers, I have plus 25 minus 20, so that's positive 5, plus 4 more. That's going to give me a plus 9. So now I have an equation to solve. X squared minus 6x plus 9 equals 0. Well, you solve a quadratic because this has an x squared and an x term, so there's no way to get x by itself. What I want to try to do is I want to try to factor this thing out. So I'm going to try to come up with two binomials here that can come out to make that expression above. So I know that the first two terms make the x squared. So I know x times x will give me x squared. I know that these back two terms, they have to multiply together to make positive 9. Well, I could either be 1 times 9 or 3 times 3. But another possibility is negative 1 times negative 9 and negative 3 times negative 3. Those are all the combinations that could multiply together to make positive 9. And I kind of know how these things work is that this middle term, my combination needs to add together to make negative 6. So going through my choices over here, these two add together to make 10, so they're out. These two add together to make positive 6. These add together to make negative 10. These guys are the ones I want. They add up to make negative 6. So I'm going to put minus 3 and minus 3. And now I'm going to use what's called the zero product property. If u times u equals 0, either this expression equals 0 or this expression equals 0. And these are pretty easy to solve. I just add 3 to both sides. And in this case, we get the same answer either way. So the correct answer for this problem is x equals 3. Now, that might have been a lot easier. If you'd have just tried numbers between 1 and 10, I guarantee you probably could have picked some numbers and put them in there and got 0 a little bit quicker than going through all that work. So sometimes guessing numbers can work out for you. All right, number 37 and 38 operate off of the same picture over here. So it says Jessica opened a bank account that earns 2% interest. All right, so remember 2% we can write as 0.02 as a decimal. Her initial deposit was $100, and she uses the expression 100x to the t to find the value of the account after t years. What is the value of x in the expression? Well, if she's earning money, she's earning compound interest, basically this is the way that the formula kind of works. You have your starting amount, your $100. If you multiply it by 1, nothing happens. You still end up with $100. But we're going to add to that 2% interest, and then we are going to do it for t years. So the actual equation would be 100 times 1.02 raised to the t power. So the value of x in this expression is 1.02. And in general, the equation is you start off with a certain p or principal, that's your starting amount. You go 1 plus the interest rate, and then this would be your time. So this is just kind of a general formula that you kind of need to know when you're doing these problems. But it also applies to all percentage problems. You have a starting amount, you're growing, you add to 1. If you're decreasing, you subtract from 1. And then your exponent is your time. So the answer to this question is 1.02. All right, number 38, same as above. So we have Jessica's friend Tyshawn found an account that earns 2.5% compounded annually. So I want to be careful there. That 2.5% can be written as 0.025, because remember, to change a percent to a decimal, you basically move it 2 places to the left. So that's where I got 0.025. He made an initial deposit of $100 into the account at the same time she did hers. After 10 years, how much more money, so how much more, not how much total, but how much more money will his account be than Jessica's? So let's compare them side by side. You put in $100. Tyshawn got 0.025, so I'm going to go 1 plus 0.025, and the duration is 10 years, and we're going to get his amount. And then we're going to compare Jessica, who started with $100. It grew, so we add it to 1. Hers was 0.02 because she was only 2% for 10 years. And we're going to calculate both of these. And his account, when I put this in my calculator, came out to be $128.01. Her account came out to be $121.90. So the final question says, how much more will he have? So you need to take these two numbers and we need to subtract them. 128.01 minus 121.90. And I think he would have $6.11 more. So that's basically just being familiar with compound interest equation. So again, it's always your starting amount, called your principal, times 1 plus the percentage rate as a decimal, and then your time is your exponent. That's the general formula for these ones.